Searchlight Scientific is a next-generation data services company, focusing on developing and growing cloud-based solutions to solve tomorrow's computing challenges. Everybody is sure that cloud computing is key to the future of IT, but people often seem unsure quite what it is. In fact, it's an umbrella term for a number of different trends, all involving the Internet and its potential to simplify the way we use computers, and extend their capabilities. The cloud is the Internet, and the term is fitting. It's large, out there somewhere, and fuzzy at the edges. Cloud computing is about putting more of your material out there and less on PCs or servers that a business runs for itself. You can do this in many ways, but with every vendor claiming to do cloud computing in some form, it has become confusing. It is worth understanding terms such as SaaS, Software as a Service, and PaaS, Platform as a Service, so as to evaluate vendor claims. There are radical differences between the various forms of cloud computing, and they do not all offer the same benefits. Below and in the accompanying glossary, we attempt to answer common questions and explain baffling terms about this new area of computing. Question: what's the point of cloud computing? Reasons vary, but often include the desire to outsource the maintenance burden of servers and applications, the need to scale systems up or down on demand, the benefit of being able to access your data from anywhere with an internet connection, and the ability to replace occasional heavy expenditure on IT with regular and predictable operational expenditure. Question: what is utility computing? The idea that businesses should not be spending effort and money on installing and maintaining complex hardware and applications, when a specialist can supply those same services on a pay-as-you-go basis. Businesses do not generally generate their own power; utilities are bought when needed. In the same way, the argument runs, essential IT services can be managed better externally. Question: what is software as a service? Pre-baked services that you access simply by navigating there in a web browser. Google Mail and Google Docs are examples of this kind of cloud computing. Question: what is platform as a service? A set of lower-level services, such as an operating system, or computer language interpreter, or web server offered by a cloud provider, on which developers can build custom applications. Microsoft Windows, Azure and Google App Engine are examples of PaaS. Question: what is infrastructure as a service? Provision of servers or virtual servers that organizations use on a pay-as-you-go basis. Amazon's Elastic Compute Cloud EC2 is an example of IaaS. In practice, cloud suppliers often provide additional services alongside IaaS offerings, so the boundary between IaaS and PaaS is ill-defined. Question: what is a rich Internet application? Modern web browsers have fast script engines and rich graphics and plug-ins, such as Adobe Flash, to extend their capabilities. A rich Internet application has applications running in the browser that have rich graphics and the kind of sophisticated user interface that at one time would only have been possible in a locally installed desktop application. The term was made popular by Adobe for applications using its Flash plugin, but it is also sometimes used to describe advanced HTML applications. Question: what is multi-tenancy? Cloud-hosted applications where multiple customers share a single application, even though they only have access to their own data. SALESFORCE.com is an example. Multi-tenancy is the most cost-effective form of cloud computing, since the software itself is shared. Question: what is the difference between public, private and hybrid clouds? Some organizations, especially larger ones, want the benefits of cloud computing but without the risks inherent in trusting their data to a third party. They can achieve this by creating a cloud-like infrastructure in their own data center. This is called the private cloud. The public cloud refers to providers such as Amazon, Google and SALESFORCE.com, whose shared services are available to all. A hybrid approach uses both public and private services. Question: what is virtualization? emulating computer hardware and software, so that one or more emulated computers can run simultaneously on a single physical computer. This is a boon for cloud computing. Service providers can use hardware efficiently by running many virtual servers on each machine in a data center. Sometimes virtual machines can be moved between company premises and cloud providers. Question: is cloud computing green? Cloud computing goes some way towards solving a problem called underutilization, where servers run constantly with little computing load, wasting money and power. Service providers use virtualization and other techniques to make full use of their hardware. The downside is that these data centers are power hungry, and we are using more of them as demand grows. The hope is that a new generation of more efficient supercomputers will make cloud computing a truly green option. Question: what is Amazon's cloud computing platform like? At first glance it seems odd that an online retailer has become a major cloud computing provider. The rationale is that Amazon took techniques for massive scaling learned from its e-commerce experience and applied them to a service offered to others at commodity prices. Services include the Elastic Compute Cloud EC2 for virtual servers running Linux or Windows, and the Simple Storage Service S3 for storing files in the cloud. Other services include database and payment services. It is a developer platform, not one with applications ready to run. Question: what is Google's cloud computing platform like? It includes email, online documents, spreadsheet, word processor, and presentation graphics stored on the cloud and edited in the browser, mapping services, payments, and a platform for custom applications written in one of two programming languages, Python or Java. Question: what is Microsoft's cloud computing platform like? Microsoft makes most of its money from traditional desktop software, Windows and Office. Nevertheless, it has developed its own cloud platform, including free consumer services such as email, blogging and online file storage under the Windows Live brand. The platform also includes hosted versions of its business servers such as Exchange for email and SharePoint for collaboration under the Business Productivity Online Standard Suite, and a platform for custom applications, called Windows Azure, which also offers online file storage and database services. In addition, Microsoft offers software to organizations building their own cloud platforms. Question: what is the SALESFORCE.com cloud computing platform like? The core of the platform is a multi-tenanted application for customer relationship management. It has extended this with a platform for custom applications called Force.com, which uses its own unique programming language called Apex. Most recently it has added integration with social media such as Twitter and Facebook, and the ability to run enterprise applications in Java thanks to a partnership with VMware ARE, a specialist in virtualization. Question: what are the risks? Cloud computing has real benefits, but there are also reasons for caution. Risks include loss of service if your provider has downtime or goes out of business, regulatory problems when personal data is stored internationally, security concerns when users lose control of how their data is protected, one-sided service agreements that give users little redress in the event of a calamity, and lock-in dependency on proprietary cloud applications. The world has changed. The old-style, buy-and-build ICT market space is collapsing at an unbelievable pace. With the right communications network, your business can run more efficiently, respond to customers quicker, stay ahead of the competition and lower your cost of sale. Enterprises should no longer be making capital investments in hardware, software and maintenance assurance, but subscribing to cloud services that are secure, scalable, and flexible and that deliver tangible value to any business bottom line. Searchlight understands this, which is why it has developed a cloud-based managed service model that allows customers to sweat any investment in traditional ICT technology and applications and then migrate to a cloud infrastructure when the business case stacks up. Central to our philosophy is that we vehemently believe that a hybrid of cloud-based and headquarters-based applications will prevail. To this end, the Searchlight Cloud Networking Platform, Nimbus, provides a high-performance, low-latency, secure meeting place for carrier networks, software-as-a-service providers, and legacy IT and communications infrastructure. While technology is changing, and our Nimbus leads the way in cloud communications, it's the overall, managed service both technically and commercially that will set us apart from the ICT crowd. What is HPC? High-performance computing, or HPC, is the application of supercomputers to computational problems that are either too large for standard computers or would take too long. A desktop computer generally has a single processing chip, commonly called a CPU. A HPC system, on the other hand, is essentially a network of nodes, each of which contains one or more processing chips, as well as its own memory. Parallel computing. Programs for HPC systems must be split up into many smaller programs, called threads, corresponding to each core. To piece the larger program together, the cores must be able to communicate with each other efficiently, and the system, as a whole, must be organized well. Programs on HPC systems create a vast amount of data, which can be very difficult for standard file systems and storage hardware to deal with. Standard file systems, or those defined for personal use, might have an upper limit on file size, number of files, or total storage. HPC file systems must be able to grow to contain and quickly transfer large amounts of data. In addition to data in use, researchers often keep previous data for comparison or as a starting point for future projects. Older data is kept in archival storage systems. Kraken, for example, uses a magnetic tape storage system, which can store several petabytes, millions of gigabytes of data. Applications include biochemistry, protein folding, attempts to determine the overall shape of a protein based on the sequence of amino acids. The effort may lead to better understanding of biological processes and new medicines. Protein-ligand interactions play a huge role in biological processes and are common targets for medicine. Refining computational models allows new medicines to be developed more efficiently. Chemistry, materials research helps to identify new materials, such as high-temperature superconductors, affordable electrodes for fuel cells, efficient catalysts, new methods of energy storage, etc. Physics, simulations of stars, help astrophysicists interpret observations. Environment modeling, the simulation of earthquakes, can be startlingly complex. These simulations can be used to predict which areas are likely to experience a large earthquake, and what the conditions will be. This work helps inform building codes, development planning, and emergency action plans. Weather patterns are notoriously difficult to predict. Supercomputers model weather around the country, and weather models are particularly important during hurricane season. Additionally, new computational models may be used with old data to gauge the model's usefulness in predicting weather patterns. Global climate change is a contentious topic these days, in large part due to the extreme complexity of the problem. As computational models improve, we may be better informed in our policy decisions, and able to act in a more unified manner. Industry products prototyping is often an expensive and time-consuming process. Computer modeling can reduce the time and cost of physical prototyping and make optimization much easier. This process is essential not only for obvious industries such as the automotive, aerospace, and pharmaceutical industries, but a wide spectrum of consumer products, from dishwashers to potato chips. Services, many corporations handle large amounts of data and deal with complex routings or decisions. Insurers, for instance, use models to calculate risk, while the oil-gas industry uses seismographic data to determine where oil and gas fields are located underground. Walmart optimizes supply chains, and FedEx monitors and routes packages. The financial sector uses models to spot trends and calculate risks. This is the end of Part 1, view Part 2, for the rest of the presentation.